It says the value of E is an irrational number, a non-terminating, non-repeating decimal, and like the number pi, it is a universal constant. And there's E to 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places. It's got an infinite number of decimal places. And so if you, what would you want to graph it? You would graph it just like anything else. It's an exponential. We normally, by the way, if I'm going to use E and I don't have my I don't have either my grapher with me or I don't have a scientific calculator with me, I might say approximate E by 2.7. So if I'm looking at it, I could say E is approximately 2.7. So if I were looking at, say, E to the x, it's approximately 2.7 to the x. So it's an exponential, just like any other exponential. Just like any other exponential. So you don't treat it any differently. The only difference is that we can take our handy-dandy calculators, whether it's our graphers or whether it's our little baby TI 30s, and just put in x and get out y. So if I want x is equal to e to the x, so -2, -1, 0, 1, and 2, this would be e to the -2, e to the -1, e to the 0, that's easy, that's 1, e to the 1, that's easy, that's 2.7, e to the 2. Then I put it into my handy-dandy little calculator, and we find out that this guy is approximately 0.1, this one is approximately 0.4, e squared happens to be approximately 7.4. And I got that using my calculator. So now all I need to do is graph it. Now I wish I would have run your papers on a darker setting. It probably would have been better in terms of the grid. You would have had a nicer looking grid, more like this one. So -2 is 0.1, -1 is 0.4, about a half, and 0 is 1, 1 is 2.7, 2 is about 7.4, and then there it is. He looks like any other exponential. Now, if I'm looking at e to the x plus 2, I've put in x, and I'm going to get out on x plus 2. Again, the domain is all real numbers, -1, 0, 1, and 2. So this would be e to the -2 plus 2, which is e to the 0 or 1. E to the -1 plus 2, which is e to the 1, or e, which is about 2.7. E to the 0 plus 2, which is e to the 2, and I calculated that out before, it's 7.4. E to the 1 plus 2 is e to the 3, and e to the 3, I'm going to have to calculate out, so second e to the 3 is about 20. And e to the 2 plus 2, I'm already over my limit here, e to the 4, and e to the 4 is about 54.6. That's already well off my graph paper. I'm going to be able to go to 7.4, that's about it, and then it's going to take off on me. So that at -2, we've got 1. At -1, it's 2.4, about 2.5. At 0, we're at 7, at about 7.5. And at 1, this thing is up here somewhere. So if I just connect the dots, and then we know what it does. It's an exponential. It rides along the x-axis and then out. There he is. He looks like just any other exponential function.